I left off just starting to think about what looked like a relatively simplistic error in code generation. And I'm just going to, that was easy to get to. Like an assert will go off here, and then we just look at that particular bytecode instruction. So what's happening is we have some array, and it's a statically sized array that's 64 bytes wide, but it's like trying to be passed to a varargs routine as a single 64-byte copy, which is not at all what's supposed to happen. What's supposed to happen is we're supposed to plunk a count in. We're essentially supposed to coerce it to an array of unknown size for the varargs. And we're not correctly doing that anymore. We used to because we demoed this. So what I can do is say, what is BC error S? And I can say, where did we set that? Conditions BC error S is equal to whatever. So we're going to find out who generated that instruction. We are going to find out. No, we already are finding out. Okay. Emit code for unknown array init. Okay. Visual Studio is stupid. We're on one of these instructions and not on this one down here that it's highlighted. It used to do this correctly many years ago, and then they broke it. But it's this one because it's the only one that makes sense. So that's interesting. All right. Okay, so we're doing this looks right to me. So what happens is we get a register in here that tells us what is the pointer to the data, or what's the pointer to the data, what's the count of the array. That's already been done, that's passed into us. So the bug is actually different. The bug is that the type, we're using the type of the register. We'll step back a second. So maybe it'll make it easier to explain. So our value register, where does that come from? Okay, so we emit for this expression, and we get the problem is that there's a type tag associated with this bytecode register that says it's 64 bytes big. And we either need to generate it as 8 bytes big, yeah. I can fix that right here, and we'll have an extra copy. Okay. We have a pointer to the array in our value register, but we can't use it for code generation because it is type tagged to be the length of this the size of the pointer to that data, and this will screw up the assignment. So we need to make a new register with the proper size. Hopefully this okay. So what is the best way to do this? Now, you know what? Maybe I handle this in a different way. I think it's under literal. Array literal. So this is the code that I think, yes. Yeah, this is a bug that could have showed up in a much sneakier way. Let's see. Okay, so we're just not going to change that code there. And, we're going to see what happens. Program runs. The program runs. We fixed bug 10. There is a note that I want to make, which is the following, from stuff that we did earlier today. Handling of bytecode respecialize should probably be made more robust. Instead of letting the size be wrong and doing the stupid hack we streamed on the morning of 4 October 2017, we should just pause the bytecode thread and have it wait for the respecialized struct to flow through the compiler in the normal way. So that stuff like body text works and other arbitrary routines work fine. This is a relatively big change, but I want to do it because it seems like the right thing and it seems much more solid. So the goal is to get rid of this and the policy size struct and struct as building sized. Well, oh, before I check this in, so this is release build running on Sokoban, and this should hopefully run, but release build doesn't have any of these changes. So I just wanted to verify that that works, and now let's hope that we didn't screw up anything really bad and that Sokoban still compiles and runs. Oh, goddamn. Let's ignore that and see if it's still... Let's build the release build compiler and see if it still builds Sokoban. Debug struct sq highest pipe exited greater than equal to pipe size and type table. I don't know how bad that is. That might not really be bad. Oh, it is bad. We screwed up Sokoban, so we can't check this in yet. All right. That's going to be my goal, try and fix Sokoban, and if I do that, I can go to bed. All right. Let's take out my other breakpoints. Oh, yay. Yeah, it's not good to break Sokoban. It's true. Hopefully it's not too bad. I am kind of tired though, to be honest. I've done a lot of streaming today. Debug. What is debug? It's the type of this declaration, this constant declarations expression. Okay, what declaration are we even talking about? Come on, watch. Stupid bugs in the watch window. Decal expression. No, decal line number. Decal file name. Catalog. All right. Line 22. It's a parameterized struct. Okay. That is not the biggest surprise in the world. I'll tell you that. Why is it constant? Wait, maybe it's one of the parameters. Value type. Okay. So this is in the constants block of the struct. Wait, what? Oh, the value type is another struct itself. That's fine. So all I can think of is, you know, when, so there was a point in struct polymorph which we were editing this morning. And, you know, it used to, no, not in, Oh, it's in the other overloader struct polymorph. So remember, it used to put all this stuff in an array, and then we passed that to a thing that filled out the arguments block. And all I can presume is that old version that filled out the arguments block. No. Okay, here's the thing. This thing here. This thing here should have yielded. If a type wasn't ready. So what we're getting here is like, look, this thing is a struct, and it's still in infer. What the hell are you doing, guys? This struct is still in infer. Why are we, why are we trying to size somebody else when we don't know what the type of one of its constituents components is? So we should have caught that. So the question is, why didn't we catch it? The pain here is that this scope doesn't point back to its own struct. Okay, so I'm going to do this. The enclosing scope of this declaration is a struct arguments block, and its serial number is this. So in struct polymorph, is that where we are? Yeah. I'm going to set a breakpoint. Result desk arguments block s is equal to that. So we'll see what happens when we are making this. There's only one argument. We're stepping in here. It is a type. So like I said, we should catch this here. I guess we just don't. I guess we don't actually check that it's ready. I guess I need an additional check. So if this args, so if we cast this to a type definition, it's an animation name struct. So we can look at that, we can look at the struct description, we can look at the header, and we just need to make sure that its highest pipe exited is greater than or equal to pipe size. Okay, so if arg type is equal to ask type definition, arg if defin struct desk and defin struct desk header then if defin struct desk header highest pipe exited is less than pipe size, this type is not yet ready, yield on it. Can we not yield here? Wait. No, we can, right? Maybe we can't yield in struct polymorph right now because we didn't provide a way to do that. That would be bad. Return null if yielding or error. Well, all right. That's fine. Where were we? Which editor was I even typing in? I'm so tired now. I thought it was this one. Yeah. So see if that does something. Unhandled type in translate type. What you talking about, Willis? This must be the defined type of the struct that we yielded on. So when I return null here, I have to remember, this is a little bit error prone. But remember when I said if I don't report an error and I yield, I have to unqueue this guy. Still didn't matter. Same damn thing. Why? What is it? Animation graph catalog. This is a... Oh, the type of this thing is just completely out of whack. It's type definition with no sensible fields initialized. Where does that come from? Probably its expression. No. What? All right. Let's breakpoint in that. Putting data breakpoints here is slow, but sometimes you got to do it. Sometimes you do what is needs to be done. What needs must. All right. So this is when we're creating that declaration. Set parse time. And then we're going to set a data breakpoint on the inferred type. Let's see who sets it. It's called result here, not decal. New data breakpoint OX3556EE8. Come on, man. That'll be a faster data breakpoint, I presume. Oh, I still have to take out this one. All right. So, oh, right. Line 175. So here's what's I can tell you already what's happening. Or my theory anyway. So this is an animation graph catalog, and that is defined as this type catalog with an argument animation graph. Now what's happening is we're trying to eval this. It's trying to yield because animation graph is not ready. I don't know why it didn't do that successfully before, or why it did and then it broke. I have no idea why this broke, but it broke. We put in our fix for it, but it is now not correctly handling the fix. Although I have a question. Why did we need to know the size? That doesn't make sense. Why did we decide we need... Okay, I'm going to rewind. Because this whole yield thing that I added, this is one way to do it. It will add some substantial complexity. But, you know, we can add that and successfully require us to know the size. But I'm not sure why I need that. So let's go back. Let's go back to here, which is the assertion we were hitting in the first place. Why am I asserting this? I don't think that's necessary. I don't know why we're insisting on that. That's just a thing about type info that doesn't, it's a constraint that we don't need. Hey, maybe there's, whoops. Maybe there's actually no problem if we get rid of that. Oh, should have already computed struct size. All right. That's a serious thing. Maybe that's why I had that debug assertion in there, was to catch this at an earlier time. So here we're calling, we've got an expression in global data. So is this, that's 8170, is that the same as this? No. Well, this is that animation names. And it's being sized, it hasn't been sized yet. And this is a catalog of animation names. So really what happened was when we created this struct, when we polymorphed it, we really, instead of yielding like that, really all we need to do is say, there needs to be a size dependency. We can't size this struct until we know the sizes of its arguments. Probably. For some real code, that may be too tight of a constraint, but to be correct in the general case without further analysis, we need that. So instead of this, I'm going to say if well, we'll do this. Depend result desk define struct desk header pf size. That puts a size dependency between those guys. And then it's fine. We don't have to yield. We can return back and say, okay, this struct is comprised of these things. We just can't size it until later, which is fine because we don't need to size it until later. Oh, dependency bugs. Dude, the whole thing, these dependency bugs are a large part of the complexity I deal with day to day, and they're things that C++ isn't even trying to do. Like, if I wanted to drop to C++'s level, I wouldn't need any of that stuff. All right, commit. Fix all the problems that we're keeping the program in bug 10 and working. It was several bugs, actually. Any questions about what happened there? This may be a short stream, but like I said, I streamed a lot today, and I'm a little tired, and it's always good to go out on a little success note like that. It's not only success of fixing the bug, but I was about to do this convoluted bad thing. And instead, I did something moderately better. Oh, come on. Oh. Many, lol, but I need to study more. Studying more is not a bad thing, that's for sure. You know what, before I go off, I'm just going to take a peek at bug 9 because it's the last one from this swath of bug reports. Bug 9. This, I think, was a dependency problem. Yeah. Those are never fun. So we'll take a look at that next time. But it depends. I just want to look at it real quickly. So that's that. That's the run directive there. Depends on stuff in line 104, which is that. And that's stuck. Well, line 295. What? What? Oh, it's a custom subscript operator that we're not able to infer for some reason. All right, well, we'll attack that tomorrow. I just wanted to know what it is. Do I pay myself time and a half when I do overtime? I don't really. I mean, I guess, you know, for legal purposes, you have to pay yourself so that they can tax you correctly. But it's not based on, it's just a number that happens. It's not based on my performance. Thanks, everybody. I'm going to hang up. I'll post this tomorrow as well as the other talk that happened today. And we'll maybe dive into this operator overloading problem tomorrow.